Okay, so for example, where to, just to round it up before we maybe have 2 minutes time for questions, only we are very late, where to use those processes in the overall design process. The first one is the initial part selection. That is when we only have the components but not the schematic, looking at the most critical components and assessing them regarding aging, cracking, and solar fatigue. There are also other stations where we could do that. For example, for the initial part setting placement, where you have 80% of your housing done, the board outline is done, and you're placing your connectors and the jacks on the side first, and then trying to understand where to place your components in the center, as Namrata showed before. So understanding where are stresses and strains high, and then trying to avoid different stages, different locations, or even put more mounting points into the board. And then we have the final bill of material, where we have the board including the specs and all the features, and we know how the board operates, where we evaluate everything together, where we have the housing as well and the critical components. Yeah, that was the final, what I just said. And then also for the manufacturing, to run through manufacturing processes and the changes that you might make later on. So that was it. What we wanted to show, so this is just again an overview of the results. It's really good because you can look at your FEA results, starting with strains, stresses, and deformations, but then also drilling down to your component to have a look what component in particular failed, so that you have then the handle to change anything that you have to change to make your board more robust for your given scenario. And then, of course, in the end, different measures and different equations are in place to take those strains and calculate the life cycle to failure predictions for you to look at how long the board will withstand and will it survive later on in the field for your intended environment. So if you or anyone has questions, you're welcome to type those in. We could cover them in the last 2 minutes. Otherwise, we can also ask or reply to questions that are coming in later. So the conclusion is, it is really, we really like that workflow because it forces the user to have minimal user input. So it's very quick to translate your PCB into a good finite element model. And then, of course, the post-processing giving you a nice and good measure to understand really how long will my board survive later on with all those different physics involved. So apply it during the design. We think that it really could help to have multiple iterations done during the design process, that you only really have to test once and then pass the test, and you can be sure that your board will then withstand all those different circumstances coming up in the field later on.